For part B of this experiment, we're going to take a look at basically what happens when I hydrolyze a few of the sugars that we dealt with in the first part of the experiment, namely starch and sucrose. Now to do that, we're going to carry out an acid hydrolysis. Generally, acid catalyzes this process, gets it going a little faster, but even still, it requires a bit of heat. So we're going to employ a hot water bath for 30 seconds, but here's the basic setup. I have already got a few test tubes ready to go here, so I've put a starch control here. This is 10 milliliters of starch solution, along with 10 milliliters of sucrose solution. They're both going to be my controls. Those are not going to get any heat, and they're not going to get any acid. What I am going to do is take some of this 3 molar hydrochloric acid, and I'm going to put about 1 milliliter of it into each of the other 2 tubes, the ones that are going to undergo hydrolysis. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Should be about a milliliter. Okay, so that should be my milliliter of hydrochloric acid in each of those. And what I'm going to do is add some of my 0.5% starch, 10 milliliters already measured out in here, to the starch hydrolysis one. We'll allow that pour to get it nice and mixed up. And similarly, I've got my 1% solution of sucrose right here, 10 milliliters dumped into this. And like I said, we're not going to bother with acid or with heat for the 2 controls. These are going into the hot water bath, and they're going to stay here for the next 30 minutes. So as you can tell by the lower level of water in this bath, this has been going for a bit. We've had about 30 minutes worth of heat, and so it's time to take these out of the bath. We'll go ahead and use our test tube tongs to do this safely. And don't need that anymore, so we'll go ahead and move this out of the way. Now, what I want to do, just to make this easy to see, so here's the hydrolyzed sucrose and starch here, sucrose there. Over here's the control. They may be in a different order when I actually set them up for the final photograph, but the end game of this is that we're going to take some sodium hydroxide here and neutralize the samples that have been in here, because otherwise the acid might interfere with our tests. So that should ensure now that everything is neutral. I'm going to take a moment here as well and mix this up a little bit. Make sure the neutralization takes. We'll grab a fresh one here as well. In fact, I'll leave this with the sucrose for the time being. Take a fresh one to do the starch. So now to check that everything went the way it was supposed to, I'm going to bring a couple of tiny tubes in at the top here. And we're going to grab a little bit of the hydrolyzed starch and put it into one tiny tube. As well as some of the original starch. Put that into the other tiny tube. And we're going to check these each with the iodine Ki solution that lets you know whether you still have intact starches or not. And I do hope that that result right there speaks for itself. Now, as for the question of whether these sugars are reducing or not, that's going to require us to run Benedict's test. I'm not going to put you through watching me set that up. You've done it yourself by now. But we're going to do that with all 4 of these tubes, the starch and the sucrose, both before and after the 30 minutes in the hydrolysis acid bath. Take a look at the photograph that shows you the final results of that, and get ready to try to explain, based on the chemical structures of the original sugar and what you would expect hydrolysis to do to it, why it is you see results changing the way that they do. Good luck to you, and I look forward to reading your thinking. Take care.